Okay, I think this 0 is the x coordinate, of course, which is this 8. It forced in 3 bits, 2, 8 and 7 is 0. And this is the y coordinate, but it should be 0. The only way I can understand that is, oh, I'm doing an OR, I think, a bitwise OR, probably with that 8. So the 1 of this 8 appears here. That's what I think is happening. And here then we have a 1, and then I do a bitwise OR with the 1 of that 8, which is again a 1. That's why we have twice the same coordinates. But yeah, I mean, the problem is clearly this 8, which is just larger than even fits in the 3 bits that we have. And the reason that happens is because the 7 is even larger than it ever should have been. I probably should concentrate on on the other hand, I could make a board of 8 times 8, I think. Then at least the 7 is not illegal anymore. And then this is a separate bug, separate from the fact that 7 still exists, is being used. Yeah, how long is it? Oh, there it is. Troop. Big file. And now record them in a different place. Well, let's do this nonsense. Oh, right. We're not crashing then. So now we get here for the first time. Yeah, this should be equal to the test itself is kind of already tested. This is position doesn't make much sense. Total boards. To move plus Y to move 1. What the hell? Oh, okay, never mind. Overall position to black to move. Fuck. Why would I be doing this for an illegal position? completely dead. Nope. Got to think of something else. That's a bit quick for version 0. Why?
Brave. The planet.
Oh, yeah. she shit. Oh, that's interesting. Loads and loads and loads of sevens. Well, I tried very hard to detect anything, any coordinate larger than 4. What the hell's going on? That's version 0 that's doing that, right? Maybe we should just turn that off for now. This version 0. Why? How? Just don't tell me I'm streaming this. Fuck this music. Oh shit. No, this is me. OBS is this. But. Anyone who was there? Was I streaming music? Yeah, we are. Heads up, we've detected audio in your stream belonging to someone else. Your stream may be temporarily. It's the opposite. Yeah, I wish I could plug through the music, but I don't know what I did. They turned the audio off. Did you guys hear music or what? And why is it hanging? Oh, because it works. We now pass everything apparently. Yeah, it prints the board. Well, in that case, I guess it just works. Can also play that version. Let's try. The rook d2 should be stalemate. Yep. King b1 is illegal. King b2 is illegal. King b3 is illegal. King c3 is illegal. Rook c1 is illegal. Rook a1 is illegal. Let's do rook d3. Rook a3, then I should take it. And then it's a draw. It stops. It's not printing it. And but it stops probably means it was a draw or something. That's strange or not? Oh, I guess could be correct. It seems that this is a faster way to maybe. Yeah, yeah, probably not. Rook d2 is the right move here, right? Yep. King d1. Yeah, this is not even super fast. Well, king c2 maybe? No, not really. Actually, yes, that is the move. King c2. And now rook d3. And then rook a3. I think we have played against version 1, so that is working then. Now I can turn off all the debug output again. Ouch. Maybe I should just use a debug channel for this. Commenting out is a bit silly, but yeah, I thought that theoretically I won't need it anymore. So, but deleting feels a bit much because I might still need it. Yeah. What am I doing? Yeah, let's comment that out anyway. Disappointed. Yeah, again disappointed. It's taking longer than I thought it would after this speed up. Definitely takes longer. Now, is this compiled with optimization or not? No, it's still reasonably fast. For 12 by 12, reasonably fast. Now, the position that takes longest is 103 ply. Wouldn't it be nice if that was our starting position and then I have to give mate in 50? Let's see if I can do that. So somehow I have to find a position that belongs to that a number of plies. It should be printed here. Let's puts it in black to move parents. If that is empty, then we stop. Or if this is empty. If it is not empty, then I could remember the last position. But it must be a position where white is to move, right? So let's say white to move. Add it, and then we are here, and it's not empty. Then I can get the first element if it's not empty, which is then this, which is a data iterator, but I need a board. And let's see how that is done. It's basically the initial position. Oh, that is a const iterator. Going to define it up there. I have to profile it. I really wonder where it is spending CPU now. Right to move made in 101 ply. Well, we have to cut off the black king with the rook in both directions. While the king is here, and therefore we have to defend the rook. But we can also just cut off the king from the rook, from reaching the rook. So if we walk diagonally this way, then probably just are able to cut it off. So I'm gonna do king b2. Now it is 99 ply, so that was correct. Now king c3, king d4, Really shocking that it is on the 10th row though, and not further away. How is that even possible? Why would that be less ply? What? E5. King F6. Oh, it's cutting us off. Oh, right, yeah, Yeah, now we have to move still diagonally, which is not possible. We could go up until it is like this. King here, kings here and here. But that might not be as easy as I thought. Maybe give check. No. It's nonsense. Huh? Hello, Stia. The topic is my program works. Let's give mate on this quarter infinite board. I don't see it. How can I give mate in 45 moves and 91 ply? You have to get to the other side of the rook before we move the rook here and then cut the king off like that, but then it walks that way. So I really don't feel like doing that. Put the rook here, doesn't help. Well, at least then I can start walking diagonally again. You might end up like king here, a rook here. Now if I move the rook, it's even in front of me. I have no idea what the best move is here. Interesting. Can I walk behind the king, around it? So you can put the rook at I12 maybe. At least you get feedback here, and if now it's made in 89, then that was the right move. And that was the right move. So I think I have to walk behind the king, like this. So now we would have to go to G5 with my king, I think. Yep, that is correct. And then king h6. So now we can start walking diagonally again. I hoped, but no. It's making me a little difficult again. Okay, I'll just go to I6. Now we can walk diagonally again. King J7. I'm still doing good. Yeah, the diagonal is the best thing at all times. We can go up, but then this would also be good. I'm gonna go do king K8. Still good. Now we have to move the rook. The rook goes into the corner. That's like logical. The larger you make this board, the maximum number of ply is always if you have to move the rook all the way in the corner. So eventually I just had to do that. L12. And again good. And now I can cut off the king. So these are both good. As long as I can go there, the next move. I'm gonna go to L9, why not? King L9. Yeah. And then we can stop it. L10. Now, from here it gets easy. Now you have to go all the way back till this corner, to the corner. I think check is not a bad move here. Hopefully. Rook J12. Yep. Now I can't move the rook, so next move it's gonna move the king here, and then I want to be able to move the king, my king here, I think, because that would be the most optimal place. So the best move is now king K10. And then king K11. And then we can move the rook down. Rook J11. Rook J10. King K10. King K9. Rook J9. King J8. Rook I9. Okay, that sucks. But it was correct, huh? No, it's not correct. I made a mistake. Yeah. Rook I9 is not the best move. Let's go back to this position. Do Rook J9. Now the same position again as before. So what is the right move here? King I9 then maybe. Yeah. Interesting. What is the right move here? If this was a normal board with an edge here as well, then I would just give check. Because if then the king goes there, or we even have a smaller thingy. I think black is just smart to stay on this diagonal. To walk around a little bit. So I just try king I9. Did already try that? No, I don't think so. I don't know. King I9. Yep, that was the move. And then I suppose king H9. Nope, that was not the move. I'm gonna go back. King I9. How about the rook down then? Rook J8. The why not move? That is correct. If you can put the rook such that the black king is in the corner of that rook, then it's almost always good. So I8 should be good. Yeah, and now we cannot move down, so now we can do the king. King H8. And then we can do rook I7. It's not good. Unbelievable. Oh, the same thing. I have to move the king over there. So it's sort of a tempo or something. Strange. Okay, I want to go back to this position. So rook up. Rook I8. And so here you have to move, I think, king I7. Yeah, but why? And then king J6. It was 45. King J6. Sorry, I said yes, but it's not true. King J6 was wrong. Oh, King J6 is wrong. Okay, let's go back to I7. .45 ply. What is the right move here then? How the hell is this not the best move? Or just go to H. Just go to H7, I think. Yes, 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 yes. And now surely can the rook go down or not? I mean, that would be very nasty. If the rook comes here, the king comes back. And then I have to do something stupid like king over here. Nobody likes that. So now maybe it's king I6. It is, fortunately, I would say, not trivial. Maybe we can also automate having why do a move. Just hit enter and then it plays itself. And then hope that I can see some kind of pattern in how it gives mate. Or print it on the board, all the places where you can go to. I need a little bit more information, I think. I'm gonna do a rook I6. That was good. King I7. This is not like the same kind of position that we had before. So king and rook next to each other, and there's a knight jump away. This, but then mirrored. But it also matters where it is relative to the main diagonal, I'm afraid. This position. Whoa, that was long ago. And then the best move here is king I7. So cross to the below the rook. That is done here also the case, I suppose. So we're going to do king I5. Yes. And then king H5. Rook I4. It's going to the edge instead of to the corner. Not a surprise. King I5. Rook H4. Yeah, down to the king or to the main diagonal. I think down is now also nice because there's only 3 things left. The king is here, we can push it in. And king I4 is not that bad. Well, that is correct. King I3. And then just rook H3, of course. King H2. The rook can give check, huh? Why would that not be a good move? Rook F3. It is correct. King G1. Guess it doesn't matter. G3. King G3. King G2. King F2. Rook D3. Ouch, that was not good. Oh, now it's here. Dang. I give check on D3 with the king here. This was the position. Now, if it isn't check, then I think it is king here, king E3. But I wouldn't know why. That is indeed a good move. Now it must be king d4. And that was not good. It was 11. Cannot go back. Oh well. I'll just give mate a slow way. Rook e3. Oh, that's 15, 16 ply, 15 ply. I had a faster way again. Rook d3. King e3. King e2. Rook d2. King d1. Yep, king c2. Oops. Nah, I think it works. But extremely disappointing slow, man. I had hoped to be able to do a board of 32 times 32. Hell, when I started this, I was aiming for 256 times 256. It turns out that 12 by 12 is already, well, 38 seconds, a wait of 38 seconds. But if you ever make it 16 by 16, it's gonna make, it's gonna be, I don't know, a long time, many minutes, many minutes. Let's profile this thing. Let's see where it spends the CPU. Oops, I mean perf. Guess you run it like that and then do the report thing. Okay, that means that we have to not play, right? So just in chess version 0 is turned off, and I don't want to play to move at the initial position. To lobdas variants. Also initial position stuff. Execution time, yeah, here. Just do a return 0, yeah. Okay, if anyone can explain to me why it spends 99%, oh, children, self zero. Okay, no, okay. Start is being called, and then the start calls this, and it spends 99.41% in the program itself. I think I want to sort this by self and not by children, right? Or am I mistaken? So here's one that is interesting. Generate edges with color. Color 1 is 67% in children, so that's the whole function takes a long time. Okay, to see call change by final symbol taking CPU time, bottom up, use perf report minus capital G. I'm gonna try question mark. Yay! So this window, pop up, down, navigate, up, down, page up, page down, space, Q escape control C, exit browser or go back to previous screen. For multiple event sessions, stop on top, switch events. No. For symbolic views, sort as sim, enter zoom into DSO threads and annotate current symbol. Escape zoom out, plus expand collapse one call chain level. Annotate current symbol. What is the current symbol then? It's probably the function. C, collapse all call turns. D, zoom into current DSO. I want to do a sort of some kind. Sort by event N in group. Press any key. Yeah. Verster. Generate edges. 83% in the children. Version 1 generate edges. Okay, that's basically doing everything. I'm just surprised that it isn't 99%. So what is it doing? Oh, yeah, okay. Edges are one thing. It's generating classification, right? During the rest of the time. So does it generate edges? Normal iterator. What the hell is this? Still a significant time in something vague to do with iterators. Construct iterator maybe? Not clear what this is. And the one for the other color. Generate edges with color, the other color. So one color is takes way more actually. This is black. To generate the edges for white takes some more time. More iterator stuff. Get succeeding boards. It's not really slow, is it? Let me see the call chain of this thing. This is called from. It says it spends 15.52% in children. And as if I add these up, then that is that. So the children are this, but start is definitely not the children. How can it say that the start, which is 1.49%, which is I have to add to the 14.03 to get this, which is child. How can it say that that is a child? It is not. Doesn't make any sense. Hey, we can go down though. Type another plus. Now we're talking. I'm going to try the minus capital G. So I think this is just a bit unclear. Equally clear, unclear, I mean. Let me try some keys. The capital S does nothing. Lowercase s does nothing. Won't switch the data file due to no valid data and selected, whatever. Same coordinate still being called. How is that even possible? That's debug code. That should not be called at all. I'm at release, am I not? What? Help? Yeah, release. Did I resource it or not? Ah! This was unoptimized. Oh, that's why it was so slow. Now we're talking. Yeah, it's gonna make a big difference. Or not. Damn it. Still slow. Well, less than 5 seconds instead of 38. Kind of 7 times as fast. Now it spent most time, I think, in, well, theoretically this and children. Because, yeah. So the add edges are the slowest things. But operator new, 25.8%. I'm continuously creating and destructing vectors, I think. That is also taking a lot of time. To a new called Malloc, of course. All belong to each other. Nobody knows what this is. What? Oh no, 22%. Completely unknown 22%. But we can press this. Oh yeah, now it becomes way more clear. Oh, there is something. Nobody knows what this is, but called something. Set maximum apply on parents. Apply calculation. Get succeeding board soon. New malloc. Generate edges. Oh, that's it. As far as we go down. Add edges. Operator new. Okay, I think one of the big bottlenecks here is the fact that I'm creating and destructing vectors all the time. If I stop doing that, how can we increase that, the speed for that? Does it reuse the same memory to some array that is big enough? No allocations. Or reuse the vector. Or allocate the vector large enough at the moment we create it. But I'm pretty sure I created a lot. The size of those things is so big that if you destruct a graph, which destructs the vectors, it takes a long time. 14.7% is spent freeing the memory that it allocated. No wonder that it takes also a lot of time to allocate it. Yep, it spends in free. So helpful, this data. It really gives someone insight in what is happening. So these are neglectable classification. The problem is linking. Why is this so slow? Add edges. Yeah. I have a lot of vectors. You could give all of them an allocator, some custom allocator or a not so custom allocator, but at least an allocator that's a little bit more efficient than just calling new and free all the time. Let's see how many vectors I have. Sorry, now I forgot again. Add edges is slowest. What? This is the slowest function. I'm just gonna have a look at it, as in that one function. So the asserts are not in this code. This takes the longest time and the only thing it does is pushback. And this one, 2 pushbacks. Must be doing that very often. Would say it at the child position? Yeah, okay. More often than the total number of positions. What hell? Why is this slow? Should not be slow, man. Come on. I guess the problem is we have 50 million of these objects and 50 million of those. And each has 2 vectors, which links with all possible moves that they can do. And especially white can do a lot of moves. Because the rook can move to a lot of places. And white is usually free to go wherever. So I could maybe accelerate this by only storing positions that are the optimal play, not all positions. Currently I'm generating these things for every possible move instead of only the optimal ones. My original design did that. It just calculated backwards from mate and then only stored the most optimal path. So I suppose that I have now a faster version than version 0. And so now I could write version 2 and then compare that to version 1. while developing it. But I'm kind of done with this project. Maybe I should just let it run for a few hours, 16 by 16 maybe, and then give me the answer that I wanted to have. Which is, if I can find that back, probably not. Sure, of course I can find it back. It was on Chess Stack Exchange. Login anywhere? Anyone? I'm already logged in. Comments. Bad gateway. Answers questions. Yep. So I want to answer my own question. My question was, you have the black king n squares from this edge, and the white rook or something is m squares from that edge, and there are positioned like this. And there's a square here in the middle, of course. I don't know where the white rook is. Its position is something like this. Doesn't really matter where the rook is, I guess, as long as it's behind the king. So this. And then I want to know and how many moves it is made. So here I have the fastest way to give mate. You do a tempo move with the rook. Then the king has to go, and then we push it away, and away, and away. And we go in front of the rook, so it still can move, and then we cut it off, has to go back in the corner, and we give mate. It cannot be fast. And that of course still holds if black only has a single row to walk in, then we can move this all the way to there. Can make this an infinitely large board, and it's just going to take on average one move plus a constant. So if this distance is 1 and this distance is a million, then white gives mate in 1 million moves or 2 million ply. But it's 7 here, so apparently plus 3. So it's the number of ply is this times 2, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. I think it's 2 times n plus 5 ply, if m is 1. And here we have a case where it is m is 2 and n is still 4. And how the hell can that be faster? Mate, this is mate in 7. What looked pretty optimal. This is faster. Do the rook. Well, it is faster, yeah, if black does that. If black uses this strategy to walk away straight from the white king, remains on the second rank, he loses as fast as in the previous case. Yeah, obviously. But okay, he's not gonna do that. And they will, it's gonna do this. Next, gonna do there, there, and now we move it there. Interesting. Then I have to do a tempo move. And he does it again. Tempo move. So now I have to move the king, of course, all the way, but the rook also. How often do I have to move the rook? Boom, 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 boom. The rook is moved and then the rook is moved again. The rook is not moved 4 times. Oh yeah, another time, but it kind of belongs to the end. So it's a bit unclear how fast this one is. And now I can ask, it's really unclear, I mean, it's just really unclear. But now I can ask my my program how fast it is at, say, a distance of 4 and then at a distance of 12. And then we will know. Right? Let's do that. So let's put black king at first distance 4, like it is here. So that's 4, 0, 1. So 0, 1, 2, 3, 4. Yeah, 4, 1. And the white king is opposite. So that is 6, 1. Oops. And the rook is on, well, behind the king. So I just always put it there relative to each other. So 7, 2. And I can introduce an n here. So it's at n is 4, and this is n. M is 2. It said 15 million. There's only 5 million. And I'm not running the thing. That was not ideal. Okay, it says that white can give mate in 17 ply. Is that the optimal play that I had here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yay. Let's see how, if black also goes to diagonally away from the king at some point. It's really weird. So rook f3. Goes straight back. No, king f2. Why not king f1? If I do king f1 and then the king decides to go down, then I can just move the rook down and then it's linear with the distance, which is definitely the fastest. At least now we are this close to the edge, maybe not, but at a large distance that threatens, so it just cannot go down then. So it has to go back and then it can repeat it. It must be linear as well. What? I'm gonna try that. King f1. Yeah, it goes back. So king e1. Oh, then it goes up, of course. Yeah. But it was still good. So now we have to do a tempo move again with the rook. Or does it not matter? Rook e3. Yeah, and then you trapped it. It doesn't want to go back, but now I can do a rook e2. That should be a good move, right? And it is. So now I can just do king d1 and king c2 and rook e3 and rook a3. It looks almost linear as well then. So what if I now put it all the way at the end, or as far as it goes? Let's see, the largest thing is n+3, and the largest what I can put into it is 11, therefore this can be at most 8. So let's make this 8. If it is linear with n, more or less, then this should be like made in 25 ply. Yes, made in 25. Oh, amazing. So you can really just force it to go back, which is only possible, I think, because you switch to one row with the rook one down. Let's see. So it is king k1. And then king j1. King I1, King H1. If black would go down, you just move the rook one down, and then you do this anyway. So I guess it doesn't really matter for black if it stays there, stays on the second row or not. King G1, King F1. Okay, now it goes one down, but probably that is then better for it or so. I don't know. I'm gonna come to try rook L2, which is good. And then the rook K2, King E1, King D1. King c2, rook k3, and so on. So, interesting. I really need a larger board. I wouldn't feel safe to try 3 free rows, so the rook 1 up, everything 1 up, with a distance of only 4. Like, I guess you can do just 4, 5, 6, 7, 8 and then see what happens. That would still be clear enough. Okay, so we try 4 and then I'm gonna make this a 3. In the end, I'll just have to... I should just make a for loop. Print all the values. The generation takes some time, and then I can print all of them immediately. The whole table is a function of n and m. That's what I mean. So if I would finish that program, okay, this is 21 pi. Well, that's nice. Whatever. We'll write it down. So for m is 3 and n is 4, we have 21 pi. And then we make this 5. And so on. Can I not just indeed make it a loop already here? Totally should be possible. This creates a board, and if I have a board, I can print apply. I don't need the rest. To return 0. 4 n is 0 is even possible, I think. Let's do the whole thing. N is less than board size minus 3. Put m here for m is 1. M is less than board size divided by 2 or something. Plus m. Okay, let's print out everything on one line for n, and then here gonna print standards out. M is m. Can even stay here on one line. And here I'll just print print in, followed by a colon, followed by the number of ply, followed by comma, and then here I print a new line. Should work. Okay, now do I get the number of ply? Okay, this is why to move I have to look up in the graph the Y2 move map, which is a vector, and then I can pass some index and then get the number of ply from that. Get the index is then the board as index. Yeah, put that inside the don't really need it now. And board 1 also. Seriously. Unreachable code, man. It's dirty, but otherwise I have to comment out all that code. Okay, I'm gonna comment out all the code. What was this? No matching constructor. Really? Yeah, consider it commented out then. Exciting moment. 3 weeks of work, and there is the answer. So this one increments with 2 ply. Both black and white move the king to the edge as fast as possible. 5, 7, 9, 11, plus 2, plus 2, plus 2, plus 2. And this one, if you go backwards, also plus 2, as we found out before. 25. Minus 2 is than minus 2 is 21, minus 2 is 90, minus 2 is 70, minus 2 is 15. But here there's something happening. But we just get too close to the edge. So if you get too close to the edge, then it is faster. It becomes faster. Otherwise we would have expected 15 here. But then again, minus 2. And here again another jump. Minus 4 again. And again minus 4. Wow. It really makes a difference. And here the jump is even 6. 6, 4, 4, 4, 2, 4, 2, 2. Now we still don't know anything. So I need a larger board to know if this also becomes 2 in the end. For large distances. That would be interesting. 4 is... No, this is 2 and 2. Again 2 and 2. and then 4. And 4. Yeah, I really need a much larger board. It could be that it is a few moves long 2, distance of 2, and then again a 4. That which would mean that it is indeed a fractional. Wow, I had not expected that. But it's still also not sure. If say I make it a board of I don't know 32, and then you see the last half is 2 2 2 2 2 2 2 2 2, then I can believe that it repeats into infinity. It's not going to be 32 times 2 and then a 4 or something like that. That would be ridiculous. Okay, this takes 4.7 seconds. Well, let's make it a bit larger, I would say. Because this is still inconclusive. And with a bit larger, I mean exactly 1 larger. So you get a feel for how fast this grows. It eats a lot of memory. What also is very interesting is if it is the same. Now this is of course the same with 1. So all the way up till there. Okay, that is the same. Is this also the same? Yeah, it must be the same. It doesn't really matter that much, I guess. That you have more room on one side. Everything is moving. Yeah, it's all the same. Now this goes again to 2, 2, 2, 2. Okay. 7.2 seconds, less than a factor of 2. But for a single thingy, I think it might grow with a factor of 2-ish every single square. Let's try 14. Damn it, man. All of them are 2 more every time. Oh, wow. Okay, let's try 16. So it takes 4 times as long. Which is 4 times, less than a minute. Definitely not possible to wait for. "35 seconds even, only." Yeah, it keeps being 2. Let's say the 4 rows is already interesting. 4 or 5 rows. So this +4, +4, +4, +2, +4, +2, +2, +2, +2, +2, +2. I don't see another 4 coming. And the 5 on is +8, +2, +4, +2, +4, +2, +2, +2, +2, +2, +2. +8. +6, +4, +4, +4, +2, +2, +2, +2, +2, +2. That's insane. That is insane. I think he can repeat the same trick. Okay, so in the end it's gonna be 2 times n plus something times m. So that is then the next interesting thing. I want to make it larger. I'm gonna wait for a long time and do it up till 20. No, I need board. Shit. That is too large. I don't have that much memory apparently. No, 18 then. Hopefully that works. Still not. Wow. No, 16 was already the maximum. I can still improve my program, but I want to stop with the whole project. Let's see. No reason to run it again. So 35 seconds, and then they filled the whole memory up already. Okay, let's see if the AI can make something of this. I bet it can't. Yeah, this is Gemini is now the most stupid one in my opinion. Consider this table. For each value of m, a list is printed in the form n k. For example, where it says 1255, 57, in the bottom left corner. M is 7, N is 12, and K is 57. Since for larger n, K seems to increase by 2 every time, we can express K as K is 2 times n plus A times M plus B. For a given n, aka a column, you can calculate K minus 2 times n and see how that column increases as function of m. Does this give us an A? Possibly function of n and or m, but preferably constant for larger n and m. In general, please describe how K depends on n and m. Oh yeah, let the prime numbers be a part of this chess problem. I don't think so. See, it really sucks that I can't do a board of 256 by 256. But yeah, that really sucks. I mean, if I could do that, then we probably could derive the real formula. A bit of a special case here. Or the 6 is a special case. At least it looks like it's +2 from n larger than m. So m is 8, then, well, larger or equal. If m is 8 and n is 8 or larger, then it's +2 +2 +2. Back to the previous one. And that seems to hold for all the m's larger than. Yeah, it could be that this is just a half of the board size. And therefore, I really need a much larger board to draw this kind of conclusions. Anyhow, I think we can do m is 5 and then see how they play. I really have to make it play against itself, I think. Or I have an idea how to play actually. Maybe I can do it. Maybe I can try it myself. Okay, so let's do m is 5. M is 5 and n is 12. If 0 else, I want to comment this one out. If 0, let's do -0 so we can still see that it is code. What kind of bug is that? -0 here and then an if 0 here and it's still highlighted. What? Just bad coding. So if 0 is special, well, it's syntax highlighting, so it's a Vim script or something. Vim script is not able to understand elif. What do I commented? Yeah, see, so does it better. Okay, weird. Why won't you code if 0 is special and elif 0 not? What it is? I don't know. I'm so confused. Undeclared identifier board. Oh, we need to construct a board and yeah, this is not enough. We need this as well. Right, so the trick here is you always move the rook here. N6. The rook N6. And then the trick is that if the king goes down, then we move the rook. And if the king goes backwards, I move the king. And then within a reasonable amount of time, if m is smaller, if n is very large compared to m, you kind of would expect n plus m then, number of moves. Which is 2 times n plus 2 times m. That is the case. Let's see if we can do that. Now, I cannot move my king this way, though therefore I must move the rook this way. So we do rook n5. And now I can still move the rook that way. So I do rook n4. And now you have a problem. Okay, king, was this a good move? Yeah, so far so good. Yeah, now I have to move the king down. So that's just extra moves, which are a function of the distance of m. King O4. And then why not king O3. And now the rook can go down again. Must go down even, I think. And now the king can come in. King N2. And now we cannot come in with the rook, which is again a special case, kind of. I think here I have to step in front of the rook, and then, yeah, not super clear. See, step in front of the rook, goes there, that doesn't help. A tempo move, I'm afraid. Tempo move with the rook, and I cannot go there. I'm going to try rook p3. Yes, that is correct. And then now we play rook m3. And then we can move the king. King m1. King L1. King K1. King J1. Yeah. King J1. King I1. King H1. King G1, King F1, yeah, rook M2, rook B2. King E1, King D1, King C2, Rook B3, and Rook A1. I think I played perfectly, apart from all the typos. 0 apply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, yep. That's how to do it. So I guess it doesn't really matter if black walks to the... Well, black kind of walks to the edge first and then gives up. Walks well. I think you could also go that way, but then the king just follows you. And in the end, yeah. Or would that be less good for black? He walks straight, 2 steps straight to the edge. Well, this is a nasty position for white. Takes a lot of moves. Let's move the king, and then the king again. And that still walks to the edge. And then we can do the rook again. Now the first time it doesn't step to the edge, because then you do the rook here, and that's very, 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 very fast. King comes here, and then it goes down, and now we lose that tempo anyway. Several rook moves before we can do this, and then we lose another tempo here. Because it's playing like this. I'll eventually lose a tempo. It chooses for some reason to delay that, but I think it could do it earlier. So eventually goes to the bottom. Yeah. I have the feeling it could do that earlier. It doesn't really matter, of course. You can do it at any point. But here apparently it's necessary. If you would go straight here, the king. Would that be made faster than in 13 moves? 13 ply? Okay, well, I'm gonna go to bed. Stuff. Interesting. It is not a bad move, is it? It is not a bad move at all. Yeah. True, true, true. What shall I say about it? Oops, could not take the ball. Yeah, just promote. What are you gonna do about it? Nothing. Yeah, nah. Time pressure. Thank you very much. Still didn't see it. He continues playing. Oh, well, great. Let's continue playing. And resign. Or continue playing. What do you think? Shall we still continue playing? If he continues playing, it's an 11-year-old or younger. No, resigns. Okay. Yeah, like I said, I was going to bed. I was attempting to go to bed. Good night.